Thank you, Olivia, and thank you, everyone. I know some of you are still having your lunch. It's a lunch break, but thank you for attending this. So, in the context of this presentation, Enabling, Empowering, and Continuous Delivery Culture, I want to talk about the principles in the context of the journey that my own engineering teams have undertaken, which in the last 3 years, which for us has been going from zero to continuous delivery. And in doing so, talk a little bit about kind of the technology path that we've taken, the challenges overcome of taking that path, and then crucially also the kind of the cultural challenges that we've undertaken and the kind of the mind shift to our engineering teams, the shift of mindset to really go from a monolithic to a DevOps type culture. And indeed to talk about the challenges that we undertaken and the challenges that we still have. But I think we've had such good success over the last 3 years. I think it's a good story to tell. I know our problems aren't unique, and indeed some of the solutions and principles which I'll outline here may be familiar as well. But hopefully you'll find the kind of the decisions and the kind of the journey we've taken and the kind of the patterns we've undertook useful as part of this. So, very, very briefly, who we are. So a lot of people may not have heard of HMH because while we have huge amount of users, and as Olivia said, we're targeted at the education industry and right down to the student and teacher classroom, and with 13,000 districts, 3 million teachers, 50 million students, nearly all of that is in the US. So our market is in the US, but actually our technology arm, the biggest technology arm is here in Dublin, up here in Pearse Street. So we have 130 engineers working on the flagship learning platform, which I'll touch on briefly. And that learning platform is providing that teacher and student experience and all these kind of capabilities, as well as providing a teacher the ability to, the data platform that we're pushing up to them, be able to kind of personalize instruction to individual or groups of students, and the students themselves ultimately to kind of take personalized learning and get recommendations and ultimately to get better outcomes. So there's a lot going on there. There's a lot of technology there. Where we are at the moment is quite cutting edge, where we're sitting on a kind of a microservices platform, collection of services with kind of data, big data pipelines and content pipelines being pushed in, and we're fronting all of this up into, and those services are kind of communicating with asynchronous protocols and running in Docker containers, and they're fronting a pretty modern application using React and other applications as well, and on Angular applications. So a lot has happened for us in the last 3 years to where we are now. But where we came from is important, I think, because we kind of pride ourselves as a company. We're actually 185 years old. We started as a pure publishing company. So books such as, for example, Lord of the Rings was published by HMH, right up to our friend here, for any of you young kids might be familiar with Curious George, which is a children's book. So up until 3 or 4 years ago, is left-hand side, books, digital content, multiple platforms. The right-hand side is, as I've described, the learning platform. So we, within engineering, an engineering group, had a lot to do in 3 years. So we had a lot to do to come from where we were, from great content to great outcomes. And our journey started in monolithic applications. And I know Nick earlier on spoke a little bit about moving to cloud. And we were very much monolithic applications. We knew we needed to innovate to meet the demands of our increasing user base, but also to innovate the new platform. And we moved, we did a lot of good things initially. So we moved to the cloud, we moved to AWS, we created a pretty standard stack that could, auto-scale, that could deploy automatically. So we had all the kind of the structures in place on the cloud, but we hit a very big problem in that we ultimately hit a bottlenecks in terms of being able to spin up environments. So we were a lot of engineering teams, 15, 16 Scrum teams and more, trying to create up services. We had a centralized operational team that would spin up the environments for us. And in a company like ours, where 4,000 employees, maybe 10% of it is engineering, that would be resistant to change, ultimately led to a lot of bottlenecks. And that in turn led to a bit of latency in how we were evolving within the engineering groups. There was a lot of kind of handoffs. It's somebody else's problem. So even though we'd moved to the cloud, we still had a lot of those problems of, different environments, testing is a different group and all of that. So we knew we had problems, and we actually almost hit with the demands of what we had to, the business demands that we had, we really had to say to ourselves, look, we need to take a step back. So we, within the engineering leadership, came back a step and kind of said, well, what are our principles? What are principles of a continuous delivery environment? What are our principles for DevOps? So it starts, with controlling your infrastructure. So this is you, and when I say control, it's the engineering teams here. The engineers here have control of their infrastructure. So the spinning up an environment, controlling how that environment is working, within, whether it's in the cloud or not, but controlling that environment completely within the engineering structure in terms of how you're allocating resources, in terms of how the cluster might work on top of the cloud. Having full control of your infrastructure programmatically is going to accelerate your continuous delivery, and we knew we needed to do that. Second is controlling your deployment. So we needed to. So we were going to. It could take, months, to go down through the environments to deploy something. We wanted to be able to get this. This has to happen instantly. We have to be able to deploy with huge amount of confidence and reliability through our pipeline, and we have to be able to do it quickly. We have to roll back quickly. I mean, ideally, I think Nick mentioned earlier on in the previous presentation about canary deployments. You can do it where you can deploy at different levels of production. But from our perspective, it was control your deployments, a must from the engineering team. Third part is control your applications or your services. So in the learning platform, we have multiple services, we have front-end applications. And what I mean by control is that preferably these applications, even if they run in a larger environment, these applications will be self-contained in some way. So can be containerized, would have bounded context, would be observable, will be monitorable, have all the right kind of quality checks in and around it. And that's an absolute must for continuous delivery culture. You need to create the infrastructure, and we need to create the tools and software so that allow our applications to be controlled by engineering teams the way we want it to be in this culture. The next is to trust your system. So that's the real part of when we are in the point of where we now have a pipeline. So we were able to deploy, we're able to apply. We have a system that we can trust that when we push software into it as a group, multiple teams, that there's enough of quality checks, there's enough of happening within that system that we'll be able to take it to the next environment with confidence, because that's the only way you'll build it into a continuous. So when you have all of the first three steps, you have to trust your system. The last part is controlling your destiny, and that's as much cultural as anything else. And it can be some of the most difficult things to solve it, but that's really giving teams empowerment, understanding within engineering teams what the definition of done is, understanding what the quality of service they're doing is, knowing within the teams and empowerments about what they're delivering on and taking ownership of that. So we listed those 5 principles, as an engineering group that we wanted to follow. And it's easy to do that, but how do we put that into practice? So we came up with the different patterns you can take and all the rest. But in our case, we did have to be quite draconian. So we sent off a team of 5 to 6 engineers, with the engineering backing, kind of a skunkworks project, which is the guy up to the right. And they went off, 5 or 6 very, very good engineers, went off to start building the platform as a service. So start building, and we'll talk about a bit of that in a minute, but they start building the infrastructure as code and the environment on top. And once they got to a place where they had a cluster and the right kind of tooling and capabilities on top of AWS that could allow applications start using it, we went for broke, and we took the team of 5 or 6 people, and they came over and worked with one of the most problematic services. And between them, a pretty tough few months between them, because from an engineering perspective, they were starting to work off a completely different stack, completely different ways of working, where it's no longer someone else's problem to provision infrastructure or control your applications and all that. It's now becoming you as an engineer need to understand the DevOps. There was a lot of upskilling, and plus there was a lot of integration, and will this work, will this perform, will it scale, all of those things as well. And we had success. We got it over the line, and with big success. But that, in funny ways, that's only the starting point for us. So it wasn't enough for us to go, well, we've deliver that, so every other team should do the same. So we're now hitting the kind of both the cultural and the engineering challenges. So there's upskilling, huge upskilling for engineers to take these sort of actions themselves to fully understand their service and how they're putting it onto the platform. And then secondly, how culturally all the teams become self-empowered through quality, through production. Everything that becomes, the whole cycle in the continuous delivery structure goes to production is their ownership. It's not somebody else's ownership. Quality, QA is not somewhere else. It all falls under the bread of an engineer. So in effect, we were no longer using a operational team. Everything was being built back into the team. So that was the challenge. So we use a line there about deliberately create and deliver tools to make the right thing the easy thing. When you cannot make the right thing easy, you must make the wrong thing increasingly difficult. And that's kind of the pragmatic way you have to approach it. It's not enough to have governance say use our platform. It has to be the tooling that's been created as part of this platform, the quality controls that we're all bringing in, the automated test, all of the stuff that's been pulled in is attempting to make the right thing the easy thing to do. And if not, it has to be tough. It has to be saying, well, the difficult course of action to take for engineers or for the engineering teams is impossible to do, because we need to have a safe platform, because ultimately we're still servicing 3 million users and 50 million students. So this was our approach, and it worked over time to the point where we're at today, where we have full continuous delivery. We'll talk a little bit about where we are, but that was the approach we had to take in terms of almost the draconian way to kind of set it up, but then have a pragmatic and behavioral way of how it gets pushed up into teams. So briefly for the technology set there is what was our platform. So we for infrastructure as code, and that given us, as I mentioned, control, transparency, and predictability, we built it on top of a Mesos cluster. So that allows us to program instances, pools of resources. It gave applications ability to share pools of resources on the same EC2 instances. So as a kind of a side, having this level of control can also be very cost effective as well. So I think the saying is that if you cloud providers can be a little bit like banks, that if you don't have a plan for your money, they'll create a plan for you. So it's kind of for us, having full control, especially in the market we were in the education industry as well, where you have we wanted full control pragmatically about how we manage our instances. So within that then, so we wanted to build a kind of containerized capabilities for all multiple applications. So we brought in Jenkins as our CI process to be able to build Docker containers, Docker images, and deploy them as individual isolated containers sharing kernel resources. Also, if we wanted to bring in new application software, for example, a new database, a new MySQL or Postgres database, we're using Terraform to provision, so engineers can do a pull request and provision the infrastructure like that. And so huge amounts of scaling, horizontal scaling, benefited hugely from that, but also we now are able to solve our principle of controlling infrastructure and also controlling deployments and making applications containerized, which means we can start putting tests in around them. They're isolated. They can run tests within the container, and they can be portable across environments as with Docker is. Additionally, we would have pushed in Aurora schedulers to run these containers and keep them running forever. So the applications could use Aurora scripts to really configure how the application will work on the platform, and with Aurora, this will keep those services running forever. So we don't have downtime, we've degradation, but our services will come back up if there's problems, if they're having glitches. So so a key point so when we have our technology stack as it was from the platform, the next focus for us is kind of shifting to the pipeline, and the pipeline is key. So your continuous integration pipeline, which it's great having all the deployment capabilities, you can run quickly, but it's no point in deploying rapidly if code is going in there and it's getting to the next stage and it's failing and we're back again and all of the rest. You can have all the means to create infrastructure and all the rest. So it starts, as we know, with test automation. So test automation is absolutely key, and especially in a very integrated environment. Like we might have in our learning platform with a front end application, you could have 20, 25 services, lots and lots of instances, but 25 services with different capabilities. And they all have to come together on an experience that has to work 100% within a classroom, fully reliable and all of that. So test automation starts, obviously unit tests, but the automated tests of being able to functional testing right from front end. So front end, great tools out there. So like you use WebDriver, or Protractor, depending on what type of application stack you have. We both Angular and React. You can use at the API level. You can use Browser Stack for browser testing. You can use for API testing. We'll use Gatling and we'll use Supertest pretty heavily. We'll use Gatling for performance testing. And point of all of this is lots and lots of tools. A lot of you will be familiar with them, but they all must run as part of this pipeline. They have to be part of your automation. Not enough just to have unit test. It has to be automation is built in, and automation is key. The way we solve it is we hire specific, like quality is owned by the team. So quality of that service is owned by the team. The definition of done for our service would include full test automation. And we may have quality engineers and they may be doing some automation, but ultimately there is much there to make sure the practice is influenced and the definition done is followed as they are. We expect the engineers to be writing and helping to write these automation tests as well. So it's very much owned by the team. Similarly, speed and stability, we need to deploy quickly, fail fast, fast feedback, strive for quick and stable execution, particularly every merge go into production. So we'll do a pull request. And a huge amount of tests will get executed straight away. We're containerizing our tests. So nothing will get through to the next environment without its whole execution of automation go through. So we have full confidence that we can get to the next environment. And you may have other integrations. In our case, we have a lot of content integrations that might need to be tackled at that point. But we have full confidence of moving between environments with the amount of automation we're doing, that we can practically every merge can go into production quickly. And we've had great experience with that. Like we can do production deployment every day with even quite a complex platform. We did 6 in one day a couple of months ago in a huge deadline that we had, and lots of updates, changes. But we've had huge success in being able to kind of move to the speed and stability of really just following this process. Monitoring, extremely important. So especially in the microservices architecture, you have lots and lots of service discrete. Every service needs to be observable. Every service needs to be monitorable and needs to be owned by the team, because you're releasing to production. Engineers are owning this. You're owning this right through. And even an organization be quite big like ours, we don't expect a support team or someone else to take these things independently. It's the engineers who have ownership of when these things go to production. So your service must be highly observable. Run scope is a common monitoring tool. We would have huge, built into both our operational platform and then into our applications, we've various dashboards and Kibana and all of these things that will make the service fully observable. We can set it up for PagerDuty or text messages from run scope if the service degrades. We rarely have a service that goes down, but it could be an issue of degrading or whatever. It needs to be looked at. Security, really important that security is shift left on security. You don't want these things to be happening in the continuous delivery environment where a security team takes a look at your application. There's so much modern stuff out there and all the rest, but we don't want that to be happening at the end of any cycle. You want it to be built into your pipeline. So some great tools out there like checkmarks for security chans. You have X-ray, JFrog X-ray, which is you can do white lists of libraries go in. So those scans need to happen in your pipeline. So the more you can do in your pipeline, the more naturally it happens where all of this trust is being built in rather than expecting someone to go off and write a test or whatever. So shifting security left is really, really important. So results, test automation reports, and I think that's part of the course. Everything needs to be exposed as reports to fast debugging, highly visible to teams. And then the last part for us is quite a big thing, is data-driven decisions. So you need to metrics, big part of it is every part of your service, there's some, in terms of CPU usage, all of that needs to be communicated. We use in ourselves. We store a lot of that stuff in InfluxDB, and we're able to visualize all that stuff in Grafana. But equally, with Google Analytics, and you want feedback. If you've got product owners part of your team, you want feedback of how your software is being used in a continuous delivery culture, and you want it done quickly. So you should be able to see straight away how your customers are using your software. You shouldn't be waiting for someone, and that can be used by. In our case, we spend a lot of time investing on a student's behavior in our software because it's a big part of the whole cycle for us to be able to deliver outcomes. So we would track user behaviors, and we would track user experience through, say, Google Analytics. So all of those things are really important for data-driven decisions, because that way you can go back in again and say, well, that's not being used, and all of that. So if they're the tools, what's the mindset changes that need to make? So philosophical, really, really important. And it's ongoing. I mean, this is an ongoing challenge with us all of the time, because we shifted the culture in the space of 2 years. But we still have challenges. Empowerment, engagement, I think we'll be talking a lot through it, is you need to give empowerment to the teams. I think all engineering teams, Scrum and others, everyone wants empowerment to be able to have control of how they deliver their software. So you want all of that within the the principles of agile development. But we constantly use the word empowerment to making sure that teams are comfortable what they sign up to. Teams own what they deliver. Teams understand what quality is, understand what a service means to be deployed. And because especially when you've got multiple teams all coming together for the same application, you need to have everyone signing up to, ownership and accountability of what they're delivering, and it's not somebody else's problem. Very, very key thing if you want to deliver quickly. Accountability and transparency. Any tooling you have, like in our company, we use Slack quite a lot for engineers, familiar with Slack, to ensure that things get pushed into Slack channels of builds if anything fails. So people know pretty quickly when there's something wrong in our system, and the engineer in question will probably know fairly fast. And the culture we try to improve in our engineering team is to make sure that everyone is transparent about what they do in an engineering term, and there's nothing being hidden and all of those sort of things. And from a management perspective, over to the right, it is important to set expectations on the quality of service and the definition of done. You do not want it to be completely 100%, well, the team decided this. You have to have some level of expectations, because that's way you can have agreement of what a definition of done. And there might be deviances between the definition of done in some teams, but you do need to have, if one team is saying security is not important to us, and we're going to bring some third-party library in or whatever, and that's going to fail further down, well, that's going to be a problem. So you do need to set expectations of the quality of service. And we do a lot of that through working groups, engineers to engineers. We try to empower that on the teams rather than from the management. So the teams, there might be some level of boundaries that we would put in place, but the teams talk to each other and they say, well, what's your definition? What's the agreed principles that we have in our definition of done? What can get to production? If some test failed, are we all saying there's not a chance that could go to production? All of those kind of rules. And that's important because it has to be built. If we're going to be giving teams the power to deliver to production, they need to have the expectation of the quality of service that they're delivering. And finally, kind of the culture of celebrating success, fail fast and learn. Really important for innovation, really important for continuous delivery is that, I think we're all good at celebrating success, but sometimes we do need to we do need to try stuff pretty quickly. In the microservices architecture especially, we've tried certain technology stacks around, and we've kind of said, well, that didn't work particularly well. And that can be okay as long as it's fail fast and we learn from the experience quickly. So we try to install that culture, because you'll move quicker. We move pragmatically, and we as a group will feel as if we're innovating faster from giving a little bit more power for engineers to kind of try something out a little bit more. So as long as the path to failing is fast, and it will be with all of the tools that I mentioned in place, you will fail fast. But I think that culture should be okay as long as we learn through our cycles. So that's all I had from a roadmap. So I want to leave a few minutes for questions. So.
Thank you, Ciaran. Thank you.